It goes to a color plane sequencer. It's clipped, and it goes through the clock video output and through the LCD panel. Software will be explained by Nima.
Okay, so the way the software works is that it starts by initializing the display and the buffer. After that, it moves on to initializing the mixer, which is the main part of the code. And they also, as Ankita explained, the mixer will take the image from the camera and the DVD player and mixes it with the camera on the foreground and the DVD player on the background. So and then it moves on to see if there's a touch. If there is a touch, then you read the coordinates for the touch, and since we added some features to it, it has to decide where the touch is, and based on where the touch is, it'll go to that function that is dedicated on the touch. We have moved the foreground image, which is moving the camera image that's on the foreground around the screen. We can zoom in, zoom out, and we can also stretch the image size by dragging the top left corner. And we can have the foreground image on or off. And then after it does its functions, obviously the graphics goes back to a touch. And then some of the hardware abstraction languages we used were the buffer, that's just for the display of the buffer. That's for the mixer set layer position, since the layer, since we have the two layers of foreground background, that's how we initialize it. And then the get pin basically reads the coordinates of the touch. And then the move image will move the foreground image around the screen, and update graphics just basically updates all the graphics on the LCD. And the string alpha basically just prints the boxes and the characters that we have on the top of the screen. Now for the demonstration. Okay, so
can you raise the board so that everyone can see?
We haven't tested it with that. Okay, so as you can see right now, we have the camera as the foreground image, and the background is a video which I have paused. If you press play, you can see that the background is the image that's coming from the DVD player, which we're playing the DVD right now. Some of the functions we added afterwards were the zooms that we explained and the on and off that you can see on the top. So if I press the minus, then you can see the image shrinking. And if I press the plus, you can see that it's also expanding. The on and off, if you press off, the foreground image goes off and it's only the background. If you press on, you can see that the image comes back. And then we can also zoom by dragging the top left. Check it if I can drag it. There you go. Then you can see the image changes its size, and then we can move the image on the background of the foreground image around the screen. That's it.
Good evening, everyone. Our group has designed a photo gallery using touch control on keypad, and my group members are Shuzi and Sagar, and we will be showing you a demonstration after our presentation. So in a nutshell, we have used an industrial processor to design our photo gallery, and we are using the VGA module to display the images on the keypad, and we are using a particular source for getting the photos from the output from the IOs to the nearest processor, and we are using the SD card for that. And we have created two user interface for a user to view the photos on the SD card. That is the manual mode and the slideshow mode. If you are using the manual mode, the user has to select the next button. We have not manually implemented the next button. If you click on the screen, the photos come up in a synchronized manner. This is a hardware design. The core consists of 4 blocks: the memory module, the ALD PLL, the data UART, and the touch controls, and the output FIFO controller. So we are using 100 megahertz of clock frequency to generate from the ALD PLL, and we are using the SD RAM. We are using the SD card input media to show the photo, and it is given to the SD map, and then it is given to the SDT image. The next part will be explained by Shruti.
So the software part starts by initializing the VGA module for showing the display on the D-pad, then the touch screen and SD card as we read the images from the SD card. So after these three components are initialized, all the images are read from the SD card. Then a screen appears on the D-pad where the user has an option of selecting manual mode or the slideshow. If the user selects slideshow, then all the images are displayed with a delay of 1 second, or else the user is allowed to go to the next or the previous image by touching the edges of the keypad. And for this we have used HALs like VGA, touchscreen and SD card, and the library JPEG, graphics and fonts for displaying the images and the graphics. And now we see the demonstration.
This is the home screen of our project. It gives the user two options, a manual photo gallery which the user has the control over to go to the next photo or the previous photo. The other option is the slideshow, which manually, automatically it updates the photo. Now, if I click slideshow, what it will do is it will read from the SD card, but we have used SD-RAM as a pixel buffer. So it will copy the image, the hex data from SD card to SD-RAM, and then it will pass on to the 5.4 to display it on the VGA. That's the reason we have some slack, we have some latency in showing the pictures. So as the image size increases, the time to display the picture increases. So the next image is almost around 200 kb, so it takes some time to display. As we'll move on, we'll see that smaller images are displayed rapidly. We have different resolutions from 800, ranging from 800, 600 to 500 to 400. As we see, this goes on automatically. The smaller images are coming rapidly. To move out of the slideshow, we have a box over here. We call it the home button. If we press it, it will go back to the next home screen. Yeah, this is the home screen. Now we'll check out the manual mode. Click on this button. After clicking on the button, the first photo is automatically loaded, so you get it in time. To go to the next photo or the previous photo, you click on the extreme 100 pixels. So that the size of our next button is 100 by 600 pixels. So when you click on this,